Hello, welcome to our very first video lesson from home and with the brand new content. I hope that you guys are actively listening the way that I know that you can, that you're using that pause button and the rewind button, and maybe even watching the video twice so you can understand the video and you get everything written down that we need to. So today we are going to be talking about square roots. So on the top of your paper, make sure you write square roots and then the date. Now, here's a picture of what I want your notes to look like in the format that I'm expecting you guys to write your notes in. I also uploaded this onto our website so you don't have to keep flipping back and forth. So as you can see, we just wrote the title, square roots, and then the date. Okay, so in a little bit, I'm going to have you write the objective. You're going to draw a horizontal line across the bottom. These notes are called Cornell style, and these are the type of notes that, unless I say otherwise, that we're going to use this year. So I might, if I were you, go on our website and pull these up and have them write side by side, this and then the video, so then you can follow along and write down exactly what I need you to write down, and then anything else that you want to add for your own good. So underneath the title, you're going to write objective, and I will need you to write word for word, I will be able to define square root, perfect square, and radical expressions. You will be able to define those at the end of this video. So the first definition that I have for you is square roots. So the term is going to be on the left side of that line, and then the definition will be on the right. So square root, the definition of square root is a square root of a number, n, is a number, m, which can be multiplied by itself, which equals n. Now, none of that kind of seems confusing in words, so I definitely have a picture example, and then we'll talk about it a little bit more in class tomorrow. But as we went over in class today, we knew that if we have the area of a square, and sometimes we want to find out what a side length is. Well, if we have a square here, right here, and the area was 9, we want to know what one side length equals. Now we know that, to find area, it's length times width or side times side, however you want to think about it. And so we ask ourselves, what times what, the same number, what times what equals 9? And so we know that 3 times 3 equals 9. So how we can write that is 3 times 3 equals 9, which is right here. And we know that we can rewrite that by saying 3 squared equals 9. But the cool thing is now we have an operation that helps us solve this problem without thinking, well, what times what equals the area? Because, yeah, sure, we know 9 now, but what happens if it were a number like 1,250? Do you know off the top of your head what the square root of, or I'm sorry, I just gave you the answer. Do you know off the top of your head what times what equals that big number? Not always. We can figure it out, but it might take a while. And so what we do is we use the square root, which is this symbol right here. So what we can do is we can write the square root of 9. And the square root of 9 is equal to 3. And what we just did was the inverse or the opposite of 3 squared. 3 squared is equal to 9, and the square root of 9 is equal to 3. So let's dissect this a little bit. So here's the square root of 9 and the symbol that we just had. And here are the different parts. So when you have a square root, you have the square root symbol, or a radical is what you call that. The square root or the radical. Now the reason why we call it a radical is because, as you'll learn later, that we can take other things other than the square root. We could do the cube root, or the fourth root, or the fifth root, and we'll learn more about that later, but just to let you know, this sign is called the radical. This part above the radical, or around this little like hump part, is called the index. Now, as you can see, there's no letter or number there right now, and that's because when there's no number, it's assumed that it's 2. And so every time you see the square root, there will not be a number. Now, you will see a number when we start getting into the cube root and other roots that we talk about. And then whatever's underneath the radical sign is called the radicand. And you might not hear that word, vocab word a lot now, but you will as you get higher into your math classes. So this is the different parts of the square root. So another thing to realize about square roots is there's something called a perfect square, or you might hear it called a square number. So this is our second term. And so the perfect square, also known as aka slash, however you want to write it, square number, will go on the left side of that line. Look at my notes if you're confused or need help. And the definition of that is a number that is a square of an integer. Okay, so my example is 16. 16 is a perfect square because 4 squared is equal to 16, and the square root of 16 is equal to 4. So it came up perfectly. There's no decimal, there's no fraction, it's a perfect square. And so perfect square, every single time a perfect square has to be a whole number, and a perfect square describes the area of a square. So if I ask you what shape is the square root associated with a perfect square, it describes the area of a square. And then if we're actually taking the square root describes one side of the square. And we kind of figured that out when we did our crime scenes in class. And so one way that we know we can check ourselves is that all perfect squares will be in the shape of a square. You can draw them as an array. So we know that 1 is a perfect square because it's itself. So the square root of 1 is 1. We know that 4 is a perfect square because the square root of 4 is 2. We know that 9 is a perfect square. The square root of 9 is 3. And that'll keep going on. For our class, you are going to want to memorize the first 20. So the first 20, and you don't have to write this down because I'm going to have a handout that we're going to glue into our notebooks, but just use this as a reference. These are the first 20 perfect squares. Okay, so a radical expression is in our next vocab word, and that definition is an expression involving that radical sign. So any expression involving the radical sign. So for example, we're going to solve the following. So the square root of 81 is a perfect square, and that equals 9. This one, the square root, so the negative square root of 169, which is equal to, and I messed up, that should be negative 13, so let me just add that pen, the negative, negative, there we go, negative 13, okay? And the reason why we have to write it like that is because, as you guys recall, if we're taking squares, 2 squared, for example, 2 times 2 equals 4. But also negative 2 times negative 2 equals 4 too. So when we're talking about square roots, actually the square root is plus or minus, positive or negative. So it equals the plus or minus 9, basically. So the square root of 81 can equal positive 9 or negative 9. In our class this year, we're basically only going to be working with the positives. So if I want the negative, you're going to see it written like this. Okay? Okay, so now, what about the square root of 37? Well, the square root of 37 isn't a perfect square, as you know. So how do we figure out what the square root of 37 is without a calculator? So the next section of our notes is going to be estimating square roots. So the square root of 37. So the first thing that we need to do is to draw a number line. And you can just draw a number line with 3 notches on it. And in that middle notch, you're going to put whatever you're estimating. So in our case, the square root of 37. So you're going to draw 3 lines. The square root of 37 is in the middle line. So now you're going to think, what's the perfect square before? Like directly before the square root of 37. So you can look at your notes, you can remember that the perfect square is 36. And then we want to think about what's the perfect square directly after it. When we think about that, or look at our notes, that would be 47, so the square root of 47. Underneath the number line, we're going to write our whole numbers. So the square root of 36 is equal to 6, and the square root of 49 is equal to 7. So because we know that the square root of 37 is in between 6 and 7, we know that 6 is going to be our whole number. Okay, so the next thing that we're going to do is we're going to find the difference between 36 and 37. So we know that 37 minus 36 is 1, and that's going to be our numerator. Then we're going to do the same thing but we're going to go with the difference between 36 and 49. So 49 minus 36 is 13, and we know that that's going to be our denominator. So when we put all of that together, 6 is our whole number, and 1 over 13 is our fraction. Now we could stop there, but sometimes we want to know, well, what is it as a decimal? Since the square root of 37 is an irrational number, it's not a number that will terminate or repeat over and over. It's just going to keep on going with non-repeating numbers. So we need to round, and we need to find that decimal. And so what we're going to do is we're going to go 1 divided by 13. And when you long divide it out, you'll find that it will keep on going. It's an irrational number. It doesn't repeat. It doesn't stop. And so I just stopped at the at right here, because I'm going to want us to round to the thousandth place. So I stopped at the 10,000th place, so then we can round. So our answer is 0.0769. So then when we round, we know that it's going to be 0.077. Okay? So then when we put it together, our answer is the square root of 37, and we want the squiggly lines. So instead of the equal sign, we want approximately, and that's really bad, but approximately equal to. So the square root of 37 is approximately equal to 6.077. Okay, and we will go over this more in class, but I just kind of wanted to get an introductory to it. So now at the bottom, if you look at my notes again, you're going to draw another horizontal line, and you're going to write questions. And you're required to write down 2 questions over what we talked about today. So question about maybe things that you don't understand that you want me to clarify. Questions on maybe where are we going from here? How are we going to use it in the future? Questions about, well, okay, this is easy. What do I do to challenge myself? How is this relevant? So any questions like that or anything else that you come up with, as long as it's relevant to what we just talked about, I need you to write those down. You can definitely have more than 2 questions, but I want you to have at least 2. And then we'll be going over those questions at the beginning of class tomorrow, or maybe today if you watched it before you came to class today. So I hope this makes sense, and that I will see you tomorrow, and we'll get digging deeper into this content and doing some practice problems together. So thank you for being good listeners, and I'll see you later.